Hey, it's Ross from rosslukeman.com. Today I want to talk to you about how to size your battery bank in your van or RV. This is a really important topic because batteries are so expensive. You don't want to overcalculate how many batteries you need and end up spending all this extra money and taking up extra space in your van or RV. And we don't want to undercalculate the battery bank because we can end up running out of power out on the road, and that's no fun either. So we want to be able to accurately calculate how many batteries we need. And we're going to do that by looking at the appliances that we're going to have in our van or RV and calculating the battery capacity that each appliance needs per day. And what I'd like to do, instead of talking about battery voltage and amperage, we are going to start out with watts. I know that you know what watts are, like a 60-watt bulb. And we're going to take a look at this toaster, which is 850 watts. So if we look at 850 watts, that's a measurement of power, and watts are comprised of voltage multiplied by amperage. So voltage is really the force of the electricity going through a cable, and the amperage is a measurement of current, or the volume of electrons flowing through a cable. And you can think of it like current in a river. You have a high current or a low current. That's talking about the volume of water flowing through the river, flowing down the river. And so the current for electricity, amperage, is a measure of how many electrons are flowing down that cable. So it's very similar to current like you would have with water. So the volume of electrons multiplied by the force of those electrons is going to equal the wattage or power. So 850 watts. And what we can do is calculate the battery capacity in what's called watt hours. And you may say watt hours, I've never heard of that, but if you think about kilowatt hours in a house or apartment, you are buying your electricity for maybe 10 cents or 20 cents a kilowatt hour. So a kilowatt is 1,000 watts running through a cable for 1 hour. So a kilowatt hour. So batteries are smaller, so we're going to measure them in just watt hours. Now, if we look at this battery, it is a 100 amp hour battery, and it is a 12 volt battery. So as I said, watts are the product of volts times amps, but we can also calculate volts times amp hours, and we'll get watt hours. So to put that all together, we can just multiply 100 times 12 here, and we'll get 1200 watt hours for this battery. Now let's break that down. How long would it run this toaster? So if we take watt hours and divide by watts, it'll spit out hours, right? So I hope you're following me. So 1200 watt hours for the battery. This thing is going to pull 850 watts, so we'll divide by 850. This battery would run this toaster for 1.4 hours. So that's how we look at watt hours. And of course, we don't need to run it for 1.4 hours. I can toast my waffles in 2 minutes, and so it would actually take not very much of this battery capacity at all to toast those waffles in the morning, and we'd have the rest of the battery for other uses. Now, watt hours is a very accurate and useful metric for battery capacity. But a lot of these batteries, including this one, don't label the watt hours explicitly. They're going to say amp hours. So this is a 100 amp hour battery, and that's basically amps coming out of the battery multiplied by hours. So what I mean is we could pull 100 amps out of this battery for 1 hour, and that would equal 100 amp hours. Or we could pull 1 amp of current, so that's the volume per second of power coming out. We're pulling out 1 amp for 100 hours. So it really doesn't matter if if it's low amperage for a lot of hours or high amperage for a few hours. You multiply the amps times the hours and you get amp hours. So 100 amp hours. And so what we really need to do for these appliances is we need to calculate the amps. And what we're going to do is take the 850 watt toaster, and we're going to divide the wattage by the battery voltage, and that's going to spit out how many amps this toaster is going to pull. So we're pulling power at 12 volts out of the battery. We're going to take 850 watts and divide by your battery voltage. So this is, I'm going to just stop here for a minute. This is a common thing that you're going to do. A lot of your appliances are going to say how many watts they take, and all the time for every calculation you're going to divide the watts by a voltage, and it's going to tell you the amperage that's going to be coming out of the battery bank. And conveniently, for every appliance, that voltage is always going to be your battery voltage. So in this case it's 12 volts. So we just take 850 watts, divide by 12 volts, and it's going to give us our amperage. So that is about 71 amps coming out of the battery to power this toaster. So I hope you're following me. This calculation of battery capacity is probably the most important calculation you'll make for a van or RV electrical system, and this is kind of the million-dollar question. So there's going to be a lot more math in this episode, but it'll pay off. This is a very important calculation because we're really talking about thousands of dollars of batteries. So we need to accurately calculate that and accurately calculate the battery capacity and not waste our money. So stick with me. We'll go over these calculations, and we're going to take the watts, divide by voltage, and get amperage for each appliance. And we're just going to do a couple examples here. I would recommend, if you need to, get a notebook and write some of this down. It may help, or go back through and watch the video a second time. So at 12 volts, this toaster is pulling 71 amps from the battery, and what we need to do now is 71 amps is our rate of current consumption. I'm going to take my own notes here. Now, what we need to do is figure out hours. So as I said, batteries are going to be measured in amp hours of capacity. So we've got 71 amps, but how many hours are we going for? And so what I'm going to do is I'm going to run the toaster, put a couple of waffles in there, and we're going to run the toaster and see how long it runs for, and we'll calculate how many hours the toaster is going to run each day. All right, moment of truth. I've set the dial where I want it, and we're going to start the timer. All right, so we've got 2 minutes and 3 seconds on the clock to toast our waffles. I'm kind of making a big deal out of the hours that the waffles took to toast, because the hours that an appliance runs is really a multiplier for the amps. So we're going to take the amps that are coming out, in this case 71 amps, and we're going to multiply that by the hours to get amp hours needed for a particular appliance. And so whether it runs for 30 seconds or 8 hours, that's going to make a huge difference in the amount of battery capacity that that appliance is going to need each day. And typically I would stay away from high wattage electric household appliances like this. 850 watts, that's a lot of power coming out of your batteries, but 2 minutes is such a short duration that it's really not going to take much battery capacity at all. Now if this toaster needed 8 hours to toast those waffles, it would blow through several of these batteries, and it would just be kind of a non-starter. We wouldn't be able to power it off of batteries. But with 2 minutes, no big deal. We do need to convert those minutes to hours though. For a lot of appliances, especially like a water pump, you're going to only run it for a few minutes a day, and so we need to calculate how many hours that is. And so you're going to take your minutes and you're going to divide by 60 minutes in an hour, and that is going to give you hours. So we're going to take 2 minutes for the toaster, divide by 60, and that is going to be 0.033 hours. So 0.033 is going to be multiplied by our amps of 71, and you can see 0.033 is it's just not a big multiplier, and so it's going to end up being 2.34 amp hours of battery capacity to toast our waffles for 2 minutes. So as you can see, not a lot of capacity. We could do that maybe, let's see, 2.5. We could do that 40 times. So we could toast 40 pairs of waffles with this battery before it was out of power. And the time, as I said, is a multiplier. So if you have 2 people in the family that like waffles every morning, you need to run the toaster twice, and for a total of 4 minutes, you could use that 4-minute multiplier, or you could just take your 2.34 amp hours and double it to 4.68 amp hours for all of your toasting needs in a given day. So that is how you would calculate the amp hours for an appliance. Now I need to do one more calculation. We are going to complicate this just a little bit. This appliance is a household appliance, and it doesn't run on 12 volt DC power. It runs on 120 volts AC power, and we're going to have it running off of an inverter. So let me bring my inverter. The inverter is going to be the middleman here, and it's going to take the battery power, change the voltage to 120 volts alternating current to run our toaster. The thing is, the inverters have a little bit of power conversion losses. So they're only about 90% efficient. And what we need to do is we need to take our amp hours and we can divide by 0.9 to account for the losses that we're going to have in heat and friction as that power goes through the inverter. It's going to waste a little bit of power. So we'll take 2.34 and divide by 0.9, and we are at 2.6 amp hours. So that is a nice round number. So 2.6 amp hours accounts for everything the toaster needs and the losses that the inverter is going to incur as that power transfers through over to the toaster. So anything that runs on household power that you would plug into a wall outlet, it's going to run through an inverter. All you do is divide by 0.9, and it's going to blow up that number just a little bit to account for those losses. So just a quick note. And that is why I encourage people to use 12 volt devices anywhere they can, because that is going to run with no inverter directly off of the battery, no conversion losses, and you're not wasting battery power to run your electricity through an inverter. So with that, I'd like to move to the next appliance. We're going to look at a 12 volt DC water pump and do the calculations a little bit different, give you a little bit of extra practice. But before we do that, if you're interested in not only your batteries, but your overall power system, I have a document that you may be interested in called the Ultimate Van Power Cheat Sheet. It's got a discussion of the 3 major charging sources, so solar, shore, and alternator power. And it talks about how they all have strengths, but they also have weaknesses. But when you combine them together in a holistic power strategy, they're going to make sure that you have a good charge source no matter where you go out on the road, so you can enjoy your travels out there and not worry about running out of power. So there's a discussion of the 3 major charging sources. There's also a discussion of different battery chemistries and the strengths and weaknesses of those. That's going to help you narrow in on which battery type is going to be right for your situation. And then lastly, there is a really illuminating diagram that's essentially going to show your entire power system on one page. It's going to show the 3 major charging sources at the top and how they come together to charge your batteries, play nice together, and how that power gets distributed to your end devices such as your toaster or your phone charger. So it's a really neat diagram that I think you'll find useful. If you want your own copy of the Ultimate Van Power Cheat Sheet, all you have to do is click that link below or go to rosslukman.com/vanpower. So with that, let's get our water pump up here and we'll do calculations for that. All right, for our next example, we have our 12 volt water pump. This is a 12 volt DC water pump, as I said, so it's going to run directly off of our 12 volt battery bank with no conversion, so it's very efficient. And the cool thing about 12 volt appliances is they often have the amperage listed on the label. So if you'll recall with the toaster, we only had the wattage, 850 watts. We had to divide by our battery voltage to get the amps. We had to do that calculation. In the 12 volt DC appliance world, oftentimes it's just going to give you the amps right away. And to get amp hours, you just have to find the hours or estimate the hours. So in this case, this is 7.5 amps, it says max. And so what we're going to do is, for our calculations, we will assume that it's always going to pull 7.5 amps, and we just need to calculate those hours. So for a water pump, This one does 3 gallons a minute. If we run it for 5 minutes, that is going to be 15 gallons of water. So assuming that that is enough water for you each day, it may be more water than you really need to use in a day, but we'll say 5 minutes, because as you'll see, it's not going to add up to much here. So we'll say we're going to run it 5 minutes a day. We're going to divide 5 minutes by 60 minutes to get hours, and that is going to be 0.0833 hours a day. So less than 1/10 of an hour. And we're going to take 7.5 amps and multiply by 0.0833 hours, and that is going to give us 0.625 amp hours per day. So not even 1 amp hour. We got a 100 amp hour battery here. Not even 1 amp hour per day to meet all of our water pump needs. So this is where some items end up being almost a rounding error. You think, oh, I got to account for my water pump. It's going to take all this power, and it ends up being almost negligible. And even with the smartphones, everybody says, oh, I got to charge my phone. How much is that going to take? And it's usually just a rounding error. It's not really going to take that much power. What does take a lot of power are the appliances like that toaster or an electric heater or an air conditioner that are pulling a lot of watts. They're going to eat through your battery capacity. But a lot of your items, even your little puck lights, 12 volt DC puck lights, they're not really going to take that much power, maybe 3-4 amp hours a day. So that is how you would estimate a 12 volt DC item, figure out how many amp hours it takes. And then in our previous example with the toaster, that's how you would calculate how to do an AC item. So I'd like to share a couple more tricks for calculating battery capacity with you. And one of them is for your air conditioners. For your 12 volt DC air conditioners, oftentimes they're going to give you those amps. Like I said, 12 volt DC items. And it may say takes 48 amps. What you're going to do is figure out how many hours a day that 12 volt air conditioner would run. Let's say that it's only going to be running for 4 hours a day. We have to remember it's going to turn off when it cools down your vehicle. It's got the thermostat, so it's not going to be running 100% of the time. And so if the air conditioner is, let's say, 48 amps running for 4 hours a day, you would calculate 160. So that would be 192 amp hours a day running that air conditioner. Now, let's say that you have no power coming in. It's going to take 192 amp hours out of your battery bank. But what happens oftentimes is your vehicle is plugged in, or your engine is running, you're driving down the road, or the solar power is coming in, the sun is shining on your roof. And so that power is going to come into the battery bank, and if there's a load there, such as a 12 volt air conditioner, that power is going to come in from solar or wherever, and it's going to go right out to that air conditioner. So if you have power coming in, it's not necessarily going to eat into your battery capacity. Now, I would recommend summing up all of your appliances and figuring out what they're going to take for one day. But the caveat, as I say with that, is that that's assuming no power is coming in during that day. So if power is coming in, it's going to offset the amount that gets taken out of your batteries, and that power is going to run directly to your appliances. So calculate what you need for one day, but you may not end up using that much in real life. Now, I also want to share a couple of meters. If you want to take readings and figure out exactly what a refrigerator takes or what a toaster takes, I have a couple of meters that are going to give us real-time readouts, and I'll introduce those now. All right, so I've got our two power meters here. We're going to talk about increasing the accuracy of your calculations. Before we talk about the meters though, let's talk about increasing the accuracy when it comes to batteries. So I've switched out the battery here, and I wanted to show you this battery has a nominal voltage of 12.8 volts. So the other battery that I had a minute ago just says 12 volts. If you have a nominal voltage label on there, that's kind of the real world voltage that's going to come out of the battery. And you can think of it as kind of an average. It could put out higher than 12.8, it could put out a little bit lower than 12.8, but 12.8 is kind of going to be the average that you'll get. And that is going to change our calculations and make them a little bit more accurate. So what you can do is take our toaster, 850 watts, and if we divide by 12.8 volts instead of 12 volts, it's going to reduce the number of amps that are in our calculation. So we increase the voltage that we're dividing by, and it's going to decrease the amps from about 71 to about 66. So that's a decent margin there, and it's going to be a little bit more accurate of a calculation. Now there are a couple of ways to look at this. If you divide by 12 volts, it's actually going to overshoot the amperage by just a little bit and give you a little bit of a margin of error. So if you want to kind of make extra sure that you have enough allotment for each appliance, you can just divide by 12 volts, and that's going to give you that little bit of extra. Or if you want extreme accuracy, you can divide your wattage, like for the toaster, 850 divide by 12.8, and that's going to be as accurate as possible. So that's a way to increase the accuracy of your calculations when it comes to the battery. Now let's talk about these meters. So I have the Kilowatt EZ. This is for your AC household appliances like that toaster, and it's going to plug into the wall, and then you're going to plug the appliance into it. And for instance, on the toaster, it was labeled as 850 watts, but when I ran it through this meter, it came out right at 800 watts. So you can see that's a significant difference. And again, that's going to increase the accuracy of those calculations. Another thing that I like to use these for is calculating the power needed for a laptop. It's hard to figure out when a laptop is fully charged, it's going to draw less power from the wall outlet, or when it's charging, it's going to draw more power because it has to run the computer and charge the battery. And so it's really nice to be able to plug that in and get real-time numbers to see how many watts your laptop is actually pulling. And that applies also to things like smartphones as well. I did a calculation on this one. It was actually 6 watts running through the Kilowatt EZ. So not a whole lot of power. So for your 12 volt DC loads, this is a DC power analyzer. And this is going to go in line between your battery and your 12 volt appliance. Now what I like to use this for is things like refrigerators, because this will not only tell you the watts, the amps, and things like that, but it's going to show also the watt hours and the amp hours. So the watts would be an instantaneous reading. For instance, for a refrigerator, it might say 70 watts, but the refrigerator is going to turn on and off over a 24-hour period, and you really need to know how much power at the end of that 24 hours, how many amp hours it used. So you could start a test at noon one day and come back noon the next day, and this will tell you how much power that appliance took as it turned on and off throughout the night and over that 24-hour period. So this will tell you directly your amp hours, and you can just plug it right into your calculations for that particular appliance. So those are a couple of ways to get more accurate. Use nominal voltage if you can on the batteries, and then also use these meters to get very accurate readings instead of just reading the label. If you want, you can take readings on your appliances and plug in those numbers. So that is a way to make it more accurate. Now, as far as battery capacity and the number of days that you need, some people want to go 2 or 3 days, but that can get really expensive. What I would advise is just to get your 1 day amount. Let's say it takes 150 amp hours for 1 day. You could go up to 200. That would give you a little bit of a margin, a little bit of extra, or you could go to 300. I think for van and RV systems, you're usually going to have a charge source within a 24-hour period, either solar or the alternator charging or shore power. You're going to have something in a 24-hour period. I think when you need to get 4 or 5 days of battery capacity, that's mainly for like emergency backup energy situations, like for a house and the power grid goes down, you want 3, 4, 5 days of capacity. I think for vans and RVs, having 1 day plus, calculate what you need for 1 day and then add a margin that you're comfortable with and that is within your budget, and that is the number that I would go with. So maybe add 33% to 100% additional capacity over your calculations. So I hope that was helpful. This was kind of an extra technical episode, but as I said, this is really important, and we're dealing with a lot of money here. So hopefully that helped you out in working on your van or RV electrical system. And as I said before, if you want more help with your electrical system, I've got the great resource of the Van Power cheat sheet. If you want to grab a copy, all you have to do is click that link below or go to rosslukeman.com/vanpower. So thanks for watching, and I'll see you in the next video.